project is SDN RYU-Controller load balancing with dynamic routing. This project is created using RYU-Controller, which performs dist algorithm to find best paths based on traffic flowing through links. Optimal path is being chosen from the possible paths. In this multi-path.py file, we have used a Dijkstra algorithm to find the shortest available path from H1 to H2, where H1 and H2 are the host. The algorithm uses mini-heap functionality to calculate the smallest path cost. This is the logic that implemented the. This is the code that implemented the logic, and we have created our code is configured to use 4 types of protocols. The type of protocol can be found using the header values. The protocols are TCP, UDP, ICMP, ARP. TCP is used for normal connection. UDP will be used for service packets for buffering. ICMP will be used when the link gets terminated to send a ping regarding link destruction. ARP is used when a host IP is known but MAC is not known. This code actually implements that logic. Now to clean up any previous net states, we are going to run sudo mn -c. To start RYU-Controller, we are entering RYU manager observe links multi-path.py. This actually starts the RYU-Controller. Now to start the network topology, we are going to run sudo python tree topology.py. The discovery of topology is done automatically, so we don't have to have a specially prepared topology. Now this will open a mininet CIL. First ping all. This test all the ICMP connectivity between hosts. Next IP ERF H1 H2. This measures TCP bandwidth between two hosts. Your TCP flow some basic topology inspections. First one, net command. This lists all hosts, switches, controllers. Next, nodes. This lists all nodes with roles, host, switch or controller. Next, links. This shows active links between nodes. Next, int fs. This lists all the network interface. Now to measure UDP bandwidth and packet loss, IP EARF UDP 10 M H1 H2. This shows UDP bandwidth and packet loss. Next, to test ICMP connectivity between two hosts, H1 ping H2. Next, to open X terminals, for H1 xterm H1. Next, for H2 xterm H2. In H2 terminal, we are going to enter IP ERF -s. Next, in node H1 X terminal, we are going to enter ping 10.0.02, which is the IP address of the H2, which is the IP address of node H2.
Yeah, the connectivity is established. We are now closing the externals.
Uh,
Now we are opening the core of the topology of PY. We have created two controllers. One controller is for backup and other one is generally actually used. We have created 9 switches for the connection part. All the links are connected as shown in the code. There are two hosts in the network topology. The costs are being calculated in the background, action performed by the thread, and the path cost is calculated via network bandwidth calculation, and the optimal path is being calculated every second based on the gathered stats. As you can see, the possible all of the possible paths are calculated via using the BFS algorithm, and the minimum path, which has the minimum cost, is actually selected using the Dijkstra algorithm, and the Dijkstra algorithm path is the final cost of the packet transmission. Traditional static routing can't efficiently handle dynamic traffic patterns, leading to congestion, underutilization, and single point of failure. Our motivation was to leverage software-defined networking principle to create flexible, programmable network that can dynamically balance load and optimizes routing in real time. In this project, there are only two hosts, H1 and H2, and generally the prime controller is the first controller, and between the H1 and H2 hosts there are actually 9 switches, and the controller RYU-Controller, which is actually the SDN controller in this project, decides along which switches should the data flow. Yeah, and it's actually real time one, and this RYU controller tries to, at every second, tries to generate the path between the optimal path between the H1 and H2. This project is actually really helpful in the real world, and it's actually a nice project. Thank you.
And this takes us to the end of our project. Thank you.